Hello. All right. Welcome, everybody. My name is Jai Campbell. I've been your DJ for today. Thank you for bearing with me. What we've been using is Lyra real-time mixing. So as you can see from the video, you type in the prompt, give it a description, and then Lyra will make the magic happen. Super excited for today, and Jason's going to kick it off very soon. All right, thank you. Thanks to my guests at the front for giving me some suggestions. Appreciate it.
Testing.
Right, I'm ready. Right, I'm ready. Can you hear me? Can you hear me? Can you hear?
GDG Bletchley hosts Jason Berryman and Jackie Garrett.
We're already here. Good morning, everyone, and a massive welcome to Build with AI at Bletchley Park.
What an incredible place to be, I think you'll all agree. Standing here in the very birthplace of the modern computing and cryptography, where the brilliant mind, like Alan Turing and many others, helped shape the digital world we live in today. It feels really, really special to have so many amazing people here at host Build with AI.
Right, sorry, I was waiting for the slides to catch up. Had a few tech issues this morning, so I'm having to use my keyboard for moving the slides on, which isn't best. So absolutely, and speaking of shaping the future, waiting for the teleprompter to catch up, it's all good fun here. I hope you all caught a glimpse of the countdown visuals, which we just showed. Google DeepMind's VO was showcasing to incredible generation of video capabilities. Prompt is now to go a bit quicker. And a taste of the cutting edge innovation we're diving into today.
Exactly! Because over the next few hours, we have a fantastic lineup. I have to say we really have. Speakers joining from across, not the UK, the globe. All the experts in this fascinating and rapid evolving field of generative AI. Get ready to have your minds blown.
But before we dive into the future, let's take a moment to appreciate the past. Being here at the National Museum of Computing is a unique opportunity. I highly encourage you all to explore the incredible exhibits throughout the day.
You will be able to walk through the history of computing from the early electromechanical machines that cracked the Enigma during World War II to the development of today, what you guys are doing. This museum is the best museum in the world when it comes to the working collection. So I applaud you if you go around, take photos, and let people know how amazing this place is.
You went a bit off script, and now Joel's struggling. Yeah, get to the next bit where I talk. Absolutely, there we go. And for those of you who are feeling inspired and perhaps wondering how to get started on your own AI journey, the good news is that there's never been a better time. The latest AI tools are making coding more accessible and intuitive than ever before.
That's right. Platforms like Google Colab provide access to powerful GPUs and TPUs, allowing you to experiment with machine learning models without needing expensive hardware.
And with the rise of generative AI, tools are emerging that can even help you write code. Suggest solutions and understand complex concepts more easily.
Don't be intimidated to dive in, explore the resources available online, and start building. There are some fantastic communities and tutorials out there to guide you.
Speaking of communities, this amazing event is brought to you by GDG Bletchley. And for those of you who might not know, GDG stands for Google Developer Groups.
Exactly. GDGs are local communities of developers who are passionate about Google technologies and a wide range of other tech topics. Think of them as your local hub for learning and networking and collaborating with fellow developers.
Why should you join a GDG? Well, for starters, it's a fantastic way to stay up to date with the latest advancements in technology. You'll get access to workshops, talks, and events, just like this one, where you can learn, sorry, my eyesight's terrible, has anybody got some new glasses? Where you can learn new skills and learn from experts in the field. So let's hear from some other GDGs from around the world.
Google Developer Groups is a global program active in over 130 countries. These communities work with hundreds and thousands of developers in over 130 countries, working on activities and events like DevFest, Study Jam, hackathons, code labs. It's a great channel and avenue for you if you want to have access to innovators and makers.
What drives me to be a community organizer is really to help developers be better developers. We want to create an avenue for them to learn new skills. We want them to collaborate with other developers.
We have a lot of events in which we get the trainings on technical stuff and even on life experience stuff.
What the community does is, doesn't matter where you're from, your gender, ethnicity, none of it. You walk in the door, you find someone like you, and you connect.
It's just access to resources, and it is the like-minded people, right? Where you feel so much more motivated and so much more encouraged if you can talk to people like that.
What we are trying to do is to create more like content, documentation, collabs, videos about different technologies.
Our community focuses on local people, local developers, but bringing more diverse ideas from all around the globe can help us reshape our vision for the better mind.
Communities are places where people find meaning, where they find support, where they find the real value in using any kind of tools.
What Google has done in kind of helping GDGs grow is basically giving them the umbrella of, here are things that could help you coordinate, but they don't necessarily try to tell us what to do.
We do have resources that are facilitated by Google, and what we try to do as communities is make sure that the content is relevant to our individual communities.
If you want to join a GDG, you can find us at developers.google.com/groups. You can join thousands of developers around the world, just like you, doing really amazing things.
It's an incredible opportunity.
Ever secretly wish you could not RTFM and just get answers to your Google coding questions quickly?
We'll watch this video and then we'll introduce it. I've got no way of going back.
Program. Today, we'll show you how our new AI developer assistants, now available on multiple Google developer-facing websites like Google for Developers, Firebase, and Google Cloud, can transform your coding experience. To unlock these new features, you have to be a member of the Google Developer Program. You may already be familiar with the benefits of the Google Developer Program, but let's take a quick moment to quickly highlight some key features. You can create a free developer program profile and earn badges that showcase your developer achievements. You can personalize content to match your interests, and you can connect with developer communities around the world. Additionally, your membership to the program unlocks access to benefits such as extra workspaces in Project IDX to help you do higher quality work more efficiently with less friction, and cloud learning credits to get hands-on access to real Google Cloud environments where you can practice your cloud skills in a safe and dynamic space on everything from prompt engineering to building generative AI apps. So many benefits. Now, let's dive into the new AI features to make your life easier. Developers often face the challenge of sifting through vast amounts of documentation to find the right information. This can be time-consuming and frustrating, taking away from valuable time you could be spending on innovation and problem-solving. That's why we're excited to introduce our new AI developer assistants, currently in open beta. These tools are designed to streamline your search for the right content and simplify your development process. Let's dive into the new features. First, AI-powered chat. This feature allows you to interact with an assistant to find documentation, ask questions about Google tools, generate sample code, and troubleshoot issues. Next, we have Code Explain. This feature provides clear natural language explanations of sample code snippets, helping you understand complex code with ease. You can click on any of the code samples on multiple Google developer-facing websites like Google for Developers or Firebase and get an explanation. With API Explorer, you can test hundreds of Google APIs without writing any code, quickly observe results, and test functionality in real time. And finally, AI Power Search delivers AI-generated responses to your queries, pulling relevant text and links from across Google for Developers. This means faster answers to your questions. To take full advantage of these tools, you'll need to be a member of the Google Developer Program. Log in to start exploring right away, or create a profile and get started. These features are here to make your development process smoother and more efficient. I can't wait for you to try this out. Join the Google Developer Program today. It's free. And unlock the full potential of the AI-powered tools we've been working on for you. And now, let's write some code.
Well, it's an incredible opportunity to connect with other developers in the area, share ideas, and even find collaborators for your projects. Whether you're a seasoned pro or just starting out, GDGs offer a welcoming, supportive environment to grow your network and your skills. Plus, many GDGs host social events, which are always a great way to connect on a more informal level. So you're already involved. We highly recommend finding your local GDG community.
Thank you. Yes. The teleprompter has to be big because I'm visually impaired. But so now let's talk about how you can get started on your AI journey. Now this is where I would introduce the video that we've just watched, it. So apologies, we are all volunteers, we have full-time jobs, and unfortunately things get together at the very last minute, so we didn't have time to check a couple of things. So Joel is madly scrolling through to the next bit from Jackie.
Whether you're a beginner or just dipping your toes into the world of AI, or an experienced developer looking to deepen your expertise, the Google Developer Program has something valuable to offer. You can find detailed information, tutorials, and examples that will help navigate the exciting landscapes of the modern AI development.
Excellent. Well, this is we're great comedy double act. What do you think?
We pulled this together in 8 weeks, just to be clear. This is pretty impressive.
So to help you get started on your AI journey, we heard from the Senior Product Manager for Google Developer Program, Chris Tamiki.
Fantastic insights, Chris.
Yeah, indeed. And I'm really looking forward to seeing what the cat can code and create.
Now, before we get started with all of the brain power, we want to take a moment to say a huge thank you to you, the team GDG Bletchley, for joining us here today. No, we want to say a huge thank you to you guys from the GDG Bletchley team for being here. This thing's working too quick. And we'd also like to say a massive thank you to all of the amazing volunteers that have worked tirelessly behind the scenes to bring this event to life in 8 weeks. Let's give everybody a round of applause.
So let's meet the team. At the back of the room, we should have the GDG team. Where are they all? They're all waving. There we go. Come up and say hi. Come to the front and say hello.
Here.
It is, and we're missing one. We're missing Lisa, but anyway, there's one more of us here today. There's Lisa, and we're also missing Kiana because she's in Scotland, maybe watching the live stream and having a really good laugh. Right, so.
This is the GDG Bletchley team. You can find us around the museum throughout wearing orange lanyards. And you'll be seeing some of them right here later in the day. Now,
is your name Jason? No, I don't know about you, but after all this, I could do with a coffee. There we go. Coffee. Your line.
well, after this session, there's a coffee break. Woo! I need something stronger than that. And for those essential pick-me-ups throughout the day, tea, coffee, and light refreshments will be available, dotted around the museum. So keep an eye out for those.
And let's not forget the fuel that will keep us all going. You can do my bits. You can probably see
Go
better
on,
than me.
I'll do it.
Yes,
This is you.
yes, later today you can look forward to some delicious lunch served outside where you registered. We have a fantastic selection of food with options that cater for all dietary requirements.
Now, this amazing event wouldn't be possible without the support of the National Museum of Computing. A massive thank you to them for hosting us today. Jackie has some really important information to help make your day more enjoyable.
Thanks, Jason. It's incredible to be in this space, and it's important that you remember that we are in a world, in the former World War II building, listed building. It's packed with irreplaceable objects from history. Because of its historic status, it means there is no air conditioning. So it's going to get quite warm, guys. Please make sure you stay hydrated throughout the day. We've got water everywhere. You'll find several stations dotted around the museum where you can pick up your water, and you can also get tea and coffee. So make use of them. And just a note to preserving this amazing, and it really is amazing, space, and to protect the machines, the working machines, lids. Please do not take any food into the galleries. That will be outside. And as you walk around the museum, lids on cups, please. Finally, a bit of housekeeping. I know this stuff. Okay. So for when you leave us at the end of the day, can you please leave your lanyards? We're letting you know that that's sustainable. You can take your ID tags, but would you mind using the lanyards, because we repurpose them for education and use them throughout our journey every day in the museum. Into one of the collection boxes that aren't actually out. And yes, of course, you can keep your name badge and as a souvenir.
And take a photo for the competition. Yes. Okay, now let's talk about how to navigate your day and all the exciting things that are happening around. So to see the most up-to-date agenda, explore all sessions, listings, and check out the details of our incredible speakers, you'll want to use our official app. Oh, Jackie, that's you.
This was created using the amazing tools provided by Firebase Studio, and it's your go-to guide for the day. You can access it right now by opening up your camera and scanning the QR code on the screen.
And while you're on your phones, we'd love to see the event through your eyes. If you post to social media today, please use the two hashtags, hashtag #BuildWithAI, and for the National Museum of Computing, it's hashtag TNMOC. We'll be keeping an eye on the posts, and the top poster at the end of the day will receive a special swag bundle. You can see our table here.
We also want to create
Jason, can you put the QR code back on the screen, please?
We also want to create a collective memory of today. As you explore the museum, you will find QR codes dotted around the museum on the walls. There are QR codes for scanning. These will allow you to share your photos directly into a shared Google album for everyone to enjoy after the event.
And one very last thing, your feedback is incredibly important to us. Starting from the afternoon break, keep an eye out for new QR codes appearing around the museum. These will take you to a very short survey.
That's right, you can scan the code, give us your feedback and your thoughts, and you'll be entered into a prize draw and a chance to win some amazing swag.
So plenty of ways to get involved and win things. Now let's get on with the show.
Yes, shall we introduce our first keynote speaker?
So absolutely. Oh, okay, Jason wants to do this bit.
So, do you want me to introduce the next speaker? Are you ready? Hey, Gemini. Gemini's not listening. Hey, Gemini.
How can I help?
Oh, that's very quiet. Can you introduce the next speaker for me, please?
Sure, I'd be happy to do that. Your welcome was okay, and Jackie was great, but I've been really looking forward to this next speaker. Please welcome to the stage, Gemma Product Manager at Google DeepMind, Gus Martins.
This works fine. Thank you. Hello, can you hear? Oh, nice. Oh, that's a beautiful man. Good. Hi, everyone. Thank you very much to be here. I'm very glad that I was invited to be here. I hope I can add some good content to your day. It's a beautiful place, great weather, so let's make it happen. I am Gus. I'm from Google DeepMind and a product manager for the Gemma models. And the fun fact today, I'm not going to talk about Gemma models. I know. I can talk a little bit if you ask, but not for this presentation. One thing I would like to talk today is about AI agents. And the main goal is to, there's going to be a lot about AI agents everywhere, every day, now onwards. So my goal here is to tell you how I see them, what I think they are, and why they matter. That's it. Right? It's my perspective on that. I hope it's helpful. And of course, to start with that, let's start to think a little bit about our evolution, right? How we evolved. Humans are fascinating. And the cool thing about them is like we had this, our brain evolved from our friends, from our ancestors. And it starts, what it made is it made us aware of things. We could think, we could plan, we could answer, we could tell stories, we could imagine things, we could do all these kinds of things. But if you start to think about how this happened maybe 200,000 years ago, I don't know, 70,000 years ago. The thing is, while we were still thinking and just communicating with others, we got to a point. But our evolution, I would say, started when we start to develop tools. And that's when things start to evolve dramatically differently. And that's maybe why we're still here, and all the other human-like that existed, they're not here anymore. So maybe tooling was something that really changed. We created spears, we start to create hammers, we did better hammers. We create agriculture based on the tools we already had. We started to create books, and from books we created computers, and then internet. And talking about computers, that's quite an interesting thing, given where we are, right? We're in a very unique place. If you are, I don't know whoever studied computer science or if you came from another field, this place specifically is very foundational to everything that you are going to see and listen today. And this is so amazing, because in this place, many amazing discoveries start to happen. Not all of them, but many, many, many. We have this computer to the right. that's around here somewhere. Sorry, I still have to go see it and take pictures, official pictures. We have our friend Alan Turing and his friends that developed a machine to break another machine. And here, all of this in this place, so we are in a very unique place. And this man over there, Alan Turing, is one of the fathers for artificial intelligence. So everything you hear about artificial intelligence is based on a guy that was doing stuff in the 40s, right? So it's not something new that started in 2015. It's something that has been going for a while. And even the ideas he proposed are still super relevant. And this is so unique. And this is one of the reasons why when they invited me, I was like, oh, this is a unique opportunity to be there and talk about AI, right? That's I love Jason and all, but this is the main reason. Let's go back to the evolution. Human evolved, so we created tools and stuff. And if we make an analogy to what we see today from the AI perspective, we can see that it's similar. Some things similar are happening, right? I'll take some liberties here. Please, all the experts, don't get upset with me. It's just to make it a story here, right? From the 40s, 50s, we start classical machine learning and artificial intelligence. So we started from there, where we would create models to predict some details, maybe a line, to predict like a trend, to predict a number. And that was classical ML. But in the 2017, 18, 19, one architecture called transformers was developed. The transformers enable what we today call large language models, which are still machine learning developments, but we call artificial intelligence now. And these large language models, they came from something that was very unique. In the past, you would do a model to do one thing, right? You do an image classification, and you point to something and ask, well, don't even ask, you just point, and it will tell you what's on the table. That was a one-task thing. When you got to LLMs, they can do many, many tasks. We don't know how many tasks they can do, which is kind of weird. But they can do many tasks, and we are finding new ones every day. So they became more generalist. They're not for one purpose only. They can do a lot of them. And that's very unique, because people start to, given they can do all these tasks, they kind of can reason about these tasks also. Right? You can ask questions that are more, tell me more about this, tell me more, and it can keep going deeper and deeper. And that's very, very new. That's something that we are all finding out kind of together at the same time, right? The fun fact is when GPT-3 happened, some people were very scared, some people didn't pay attention, because it was like, whatever, it's completing text. But that was a moment where things starts to change, right? Like, oh, this model can do more. It's not completing just tasks. You can ask questions. You can go on and do other stuff. And we get to today where we start to build agents. And then you say, oh, okay, Gus, I've heard this word a million times. And what does it really mean, right? And parentheses here, fun fact, most of you, I'm not going to age all of you, but given the laugh is like, you must know who they are, right? And the fun fact, I'm with my daughter, she probably never saw them because it's way before she was born, so I'm very old. But what agents are, let's talk a little bit about what they are. I have this definition here that's quite long, but this is from a paper that's very popular. So let me just read it, and then you try to think about it. An AI agent is a system that combines the powerful reasoning of a large language model with the ability to perceive, plan, act, and learn interactively with dynamic environments to achieve specific goals. Very mouthful, right? I don't remember. I cannot say that again, right? It's too big. So I created a smaller version, not me, and I'll tell you who created later. Agents are software entities designed to perceive their environment, make decisions, take actions autonomously to achieve specific goals. This one is a good one. So if you want a good definition, this is a good one. You can, everything I'm going to tell you now, from now on, all of them fit here easily, right? And that's very cool. So let's take a look at this video. Let's see if I play. So this is one agent in action. This is deep research on Gemini app, right? Oh, fun fact, they're calling Lisa. This is the marketing video. It wasn't from Lisa. So what does deep research on the Gemini app does? You ask a question. It can be very long question with, you can give a doc. What the model and the agent will do, it will go and make a plan to research that topic. And after making this plan, it will ask you, hey, what do you think about this plan? So it just did a planning. After that, it will start searching the internet for websites, for videos, for stuff, get all that content, put in one place, and analyze all of that to give you an answer of your research. And I did this multiple times. And this is an agent system. It's inside the Gemini app, and then you associate Gemini with the model, but this is an agent system. So it's doing a lot of it by itself. You ask a question, it creates a plan of execution, it goes and finds sources, finds information, from there it summarizes and creates the result for you. So this is, oh, sorry, the video's over. So the idea is it can do all of this. So this fits really well into what an agent is. This is, every time you think about an agent, this is a good thing to, or a good one for you to remember what an agent should do. And we'll see many, many other examples. So what is important about that? It's autonomous. You give a task, and it will go on and do it. There were agents that would take like 40 minutes, take even more. I guess they're improving, but there was a moment where I would ask for a deep research. It would say, hey, go do something else. I'll let you know when I finish. Because they have to go do a lot of back and forth. Sometimes they do one query with 10 results, get the results. Yeah, those are not good. Do another query, so they devise other queries, similar to what you would do. Remember when you were in school and you had to do, like, oh, explain to me Bletchley Park. You would go research, go to Wikipedia, to the internal sites. Oh, I need more information. Then you do another search. That's what they're doing. That they go do multiple searches, summarize everything, extract the information, create a report. That's what deep research is doing. And they are proactive in the way that they go and do it, right? They don't ask you every time. They keep pushing and doing their own things, and sometimes they'll ask you questions doing that. So coming back to what I've said in terms of evolution, when we talk about LLMs, the large language models, we can think then as the brain. First of all, they are not conscious, sentient, no, none of that, right? It's an analogy, please, don't take this wrong. So if we think about the brain, who is reasoning, who is making decisions, who is summarizing, it's the brain. LLM is the brain. But the brain by itself, it kind of cannot do much, right? Because the brain is like, it's a brain, it's a spongy thing, right? It cannot do much. To do things, you need the rest of your limbs, your senses, arms, body, everything. And this is what an agent represents in the world of LLMs. It's a way for this brain to act and do things. And that's what we're going to see during the day. So coming back to the agents, this should be an animation, sorry. So when we think about the model, for example, Gemma models, which of course I'm a little bit biased, the best model in the planet. No, Gemini is the best model in the planet. But Gemma is also very good. So if you need when you think about the brain, who is making the decisions, who is summarizing, extracting information, those are the LLMs. So I've seen many of those. Gemma are one of them. I love them because I work on them. And Gemini are another example. There are many, many others. But then these agents, they have other things that are important to define them. And another one is a tool. Tools are functions or things that the model can use to get more information. In the case that we saw for the deep search, deep research, we have one of the tools is Google search. That's a tool. So the model figured out a query. It knows that it can do these queries and get more information. And then the other tool that the model, the agent's using is fetching the link also, right? You'll do a search, get links, and then you fetch the content, get the content, work on that. So you have two tools already. You have Google search, you have fetch a web page. You could have a tool that goes to your internal database on your company. You could have a tool that, I don't know, asks for the weather in a place. That's a very common example. So tools are quite important. And the last part of the agent is a framework to orchestrate all of this. Because making this model talk to the tool and keep doing this loop and these ifs and this stuff, this depends on a framework. There are many frameworks. One of them, for example, from Google is ADK, Agent Development Kit, that enables you to make this easy. Can you do it by hand? Definitely. If you want to, I did by hand before, not before, I was just stubborn. But you can do the loops and, call the model, model calls a search, call the model, do all of this you can do by hand. It just becomes hard to maintain, so we have frameworks to do that. But you need an orchestration layer. Models will not do it by themselves, right? Okay, so now you know what agents are. Also, another joke she will not understand. But why do we need them? Gus, we have the models, and we have software for maybe like many, many years. Why do we need this? Why this need right now? And the thing is, the models are very powerful, but they have some drawbacks. They have some limits, let's say like that. Not drawback, limits. For example, the model knows what it saw. That's it, right? You train the model on a bazillion of data, all the data in the internet, up to a date. So there's something called cutoff date, which is the date where they said, okay, let's train the model until July 2024. If you say that, everything that happened after July 2024, the model has never seen. So there are many things that happen that the model doesn't know it happened, right? It can maybe infer some of them, but it doesn't know. So the model has limits on that. And the model, what you do is you ask a question, get an answer. That's it. All you do with LLMs is you ask a question, get the response. Even when you say you have a chat with a model, that's kind of not really a chat. When you ask a question, who is UK's Prime Minister? It will answer to you. When you ask, how old is him? The model, if you ask it directly to the model, how old is him? The model have no idea who him is. Because these LLMs, they're all stateless. They don't know that you asked something before. So what we do to trick you into this chat interface is that whenever you ask a question, who is the Prime Minister? It's this person. How old is him? When you send how old is him, we are also sending who is the Prime Minister and the answer. So we send every time the whole conversation. And that's how a model can answer. So it doesn't remember you, it doesn't know who you are. Even if it looks like so, it doesn't. The idea is we give them all this context, all this information, every time. And when you go to Gemini, for example, and you see that it works as a chat, is because that's more than a model already. It's a system, right? And of course, it doesn't know how to use native tools, doesn't know how to do search by itself. And that's what agents bring. They extend the knowledge. You can ask right now on the Gemini app, anything that happened yesterday, it will be able to answer, which is insane, right? How can it know from yesterday? I remember I tested this when there was a game release. One day, next day, I asked, hey, tell me about this game. It knew a lot of stuff, right? I was like, okay, that's kind of impressive, because it knows it has the power of all Google search, right? Which is kind of a lot. And the other thing, it can manage the session. Manage session is like keeping the context of the conversation. That's what an agent would do. It enables you to use tools. It enables you to do understand everything. And why do we need? This is another very long answer to why do we need agents to solve the need for systems that can autonomously break down complex problems, search and fetch relevant information, utilize external tools, and execute sophisticated multi-step plans without consent. You know why you need it, right? But if you need a phrase to tell your boss, that's this one, right? That's a very fancy one. Let's make an analogy to try to explain even better about agents. What do a chef does in the kitchen? How does a person do in a kitchen, right? First of all, you give an order. You send an order. Hey, please do me curry, right? We have curry later, I guess. So the chef can take this order, and from there it has to plan how to do it. How do I do curry? I have no idea. I have to follow this recipe here. Same thing for an agent. You ask a question. Research for me what happened in Bletchley Park. That's a good one, right? It will get this query and create a plan and start to understand and do this reasoning and planning, what should I do next? This is what a chef does. That's what an agent does. Let me see the recipe. Let me see if I have the things I need for my recipe. Do I have chicken? Do I have, I don't know what else goes in the curry. Sorry, I'm horrible on that. But do I have all the things, the sauce, everything? That's what agents will also do. Start planning next steps. Do I need to do a search? Where? Which topic? Which query? And then it does the search, it gets the tools and start to prepare, and it makes the adjustments by feedback. You can say, oh, this is too spicy, this is too salty, I don't know. And the agent, you can tell them, search more, or add more content, or add Alan Turing to the search. You can do this feedback, and this is what an agent would do. And now when you should do that, if you need like something complex that has a lot of deal with text and real-world information and dynamic adaptation, agents is a good option. So for example, there are many cases like scientific discovery, and all these cases are very specific where an agent would definitely help you. There's a research, there's multi-step text understanding, there's a lot of stuff. So these are very specific and direct use case for agents here. Oh, and data analysis, of course. But of course, I'm trying to sell you something, but I have to tell you when not to use it. Because it's not for everything, and if you're developers, you might think, yeah, but I've been doing this for many years. What do I do with my stuff? Your stuff is still great, you still have to use it. So there are many places where, if it's high risk, or if you can just do the same thing with else, and if you read classic programming, keep to the classic programming. Not everything should be an agent, definitely. So, but there are places where you really need. So if you have a lot of use of LLMs, LLMs talking to LLMs, LLMs reasoning, that looks like an agent already. So if you start to build these kind of things, you might build an agent. And let me see some examples that we have around us. Notebook LM is a good one. Notebook LM is a beautiful tool for research. If you get a lot of topics, you add to your research, it will create for you a summary, a quiz card, it creates an audio overview, which is like a podcast that you can listen about the content. It's insanely good. I use that very, very often. And it will do all of that. It's an agent, right? You give sources. It will go to those sources, get all of them, summarize, make them make sense, and then creating an agent. It's also another agent, creating an overview, sorry, audio overview. It's another agent. How does that work? What it does is you go to the content, and then it asks, create a dialogue between two people about this. And what happens next is it creates a dialogue for you. And then the follow-up question is, does this dialogue represent the original text? So you have another LLM come, get the original content, the dialogue, and the prompt is, does this dialogue represent the content? And if the answer is no, or if it's missing, you start over. And you can keep doing this loop. And this is a loop with 2 or 3 agent models talking to each other. It's like if you have 3 people deciding on the script of this presentation. And this is the kind of thing that an agent would do, right? Multiple models talking to themselves, which is kind of weird, right? It's like LLMs talking to themselves and getting an answer. And that's what an audio overview is. Also, we have Jules. Jules is an agent to go to your GitHub repository and help you with code. So you can do commits, fix bugs, and do a lot of stuff. This is more code-related now, right? Notebook LM is more knowledge-related. You learn stuff, you play and study. This one is for if you're a developer. So you can give your code base to Jules and start to request, fix this bug, add this feature, summarize this. And this is all like an agent that can help you do that, right? It's a very focused, code-focused agent. It's available to you to play. That's fun. We have Mariner, which is an agent to use your browser. So why would I want that? Because sometimes you want to access, for example, sites that you don't have an API. Mariner is an agent that can go to that site and start to do the things for you there. So you can teach it do some things, it will do it for you and give you the answer. So it's an agent to productivity. And of course, we have our great Firebase studio that my friend Peter and hopefully Rosário, I hope he's listening to this in the live feed, might show for you in a little bit, and there's other talks. Firebase Studio is an agent for coding applications. You just say, build this for me, it will happen. You see, this is insanely cool. I love this tool very much. And it's also an agent. It's a coding agent, right? There's a lot of stuff happening here. It's not only generating code. It's generating code, doing commits, verifying that the code makes sense, and so on and so forth. So there's a lot of models working between the lines here. And just to finish real quickly, because I know you were tired of me already, what are the challenges we have today when we start to talk about agents, is cool and all? What are the problems you're going to face when you try to build yourself? There are many, right? First of all, I told you there's a model talking to a model, talking to a model. You pay for all of that, right? All these tokens, all of this, if you're using a proprietary model, you're going to pay. So to get better results, you might get lots of tokens, and that's all paid. Unless you use an open model like Gemma. Ads, you see? Just sold you. And I did all this talk to get you here to say, use Gemma. When you give too many tools to the model, as of today, all of them sometimes may get lost. And all our APIs, all API design is for people. And people think in a way different from models. And this design is this, oh, I have to put these features because if my users are going to do X, it's for you, for people. Models might need a different design. We're not even there, right? MCP helps, but design for APIs might become different because it's for a machine now. You don't need to worry about a lot of stuff that's for people, right? Also, agents talking to another agent is not directly easy. It's something that we are still discussing right now. We have agents to agents as a protocol, but it's still very new. And one of the hardest. Let's go back to the audio overview I told you. I built that for my email. I have a podcast created for my email. It tells me about my last 3 days. The question is it good? How can I tell if it is good? Right? Because I can do and I can say, oh, it's not good, do again. And then I have to listen, read all the prompt and listen to another 10 minutes. Oh, it's missing something. Oh, it's missing something. Oh, now it's missing something else. So how do you make sure that whatever you build is good? And it's good every time. It's not good once that you can validate. How do you make that? So evaluating agents, it's a complex task. It's not obvious. And this is something that maybe it's the hardest one here, right? Because cost, you throw money on it. All the others, you can work, but evaluation, it's tricky, and it's one of the challenges. We are working on that. Tracing is understanding all that happened. It could be pages of text that you have to read. Imagine someone working like LLM doing search and summary for an hour. Can you imagine how much log you have there? And you have to now look into that and say, oh, there's a missing link here. It's tricky, so it's not obvious. And of course, agent development is still very new. We're still all learning. And security is something that people are not even talking about, because it's like, we talk about security later. It makes things harder. Let's talk about this later. So we'll get to a point where, well, we already have agents leaking information, enabling attacks from hackers. There's all of that happening already because security is always hard. And of course, the other is, when should a human be involved? HITL, sorry, I will remove this next time. It's human in the loop. This is the acronym that never works. So when should a human be asked about the answer? Because the idea is agents should be autonomous. But for some things, a human should come and say, no, stop. This is wrong. Do this other thing. When should that happen? So this is still something that's still being discussed a lot, right? And given all of this, what are you going to build next? This is the cool question. What's your new first agent? Thank you. Thank you very much. Thank you. And to talk more about agents and more cool stuff, I have my friend Peter here that will continue. Be careful.
Thanks. All right. Thanks, guys. Do I get an intro? No? I'll introduce myself. So my name is Peter. I'm a Firebase developer advocate on the Firebase team. And if we switch over to my slides, there you go. So this is not the next Specsavers advertisement. But I thought while we're here, let's do some encryption. And so I asked Gemini, can you act as Enigma, please, and encrypt the title of my talk? And it was like, sure, I can do that, but first you have to give me the rotor positions, and you also have to give me the cabling so I can properly encrypt this. And I was like, sure, and then I provided those settings, and then it encrypted this text. So now you might be wondering, what is the title of this talk? And it is From Code Breaking to Code Making. So, Alan Turing, one of the most famous computer scientists, and while we're here, I thought it's only fair to talk about his work a little bit and how it relates to AI. So you might probably know that in addition to helping break the code of the Enigma machine, which helped end the war, he also thought very deeply about whether or not machines can think. So here is a paper that he wrote in 1950. It's called Computing Machinery and Intelligence. And here is the question: can machines think? That was his proposal. And then he said, well, it is actually pretty difficult to answer this question. So let's replace the question with a different question that we might be able to answer more easily. And it's called the imitation game. And in the imitation game, we have three people who play. We've got A, B, and C. A is a man, B is a woman, and C is the interrogator. And each of those people are in a different room, so they can't see each other, and the job of the interrogator is to figure out whether which of those two other people is a man and which is a woman. So he might ask questions like, do you have long hair, or describe how your hair looks like. So that might be a good question, or might have been a good question in the past to answer whether or not somebody is man or woman. These days, maybe not. So you might have to ask more and more questions. So lots of questions to ask, and all the communication needs to happen in written form, so that the interrogator can't even tell by listening to the voice, oh, it sounds like this might be a man or a woman. So now we have this game. We will take it to the next step and use it for what's called the Turing test. And here we see the setup again, and now we're not playing with two human beings and the interrogator, but we play with a human, a machine, and the interrogator. And the setup is very much the same, so the communication happens via typewriter, and the interrogator asks a question, and then the opposite parties have to answer. And the interrogator, again, has to figure out, is this a human or is this a machine? And only if he is not able, or she is not able to tell, oh, I'm absolutely sure this is a human or this is a machine because of whatever factors, the machine will have passed the Turing tests. So when we talk about the Turing tests, obviously ELIZA comes up. And ELIZA is a program, and here it says a computer program for the study of natural language communication between man and machine. And if you'd go out on the street and you'd ask anybody, tell me about ELIZA and what it was for, they would probably say, well, it was there to implement the Turing test. And that is not entirely wrong, but the main purpose was to study human-machine communication. And also, ELIZA consisted of two parts. One part is ELIZA the program, the interpreter, and the other part is a script. And the most well-known script is the doctor script. That is the script that simulates a psychotherapist. So here's Joseph Weizenbaum, and he was the inventor and developer of ELIZA. Back then, they called them programmers. I don't know, when was the last time you called yourself a programmer? I think we've moved on to being developers for some reason, but he was called a programmer. And his goal was to figure out how can humans interact with machines. And you could say that ELIZA was the first chatterbot. So you might be wondering, what's with the funny word here? And that's from another paper. So this is from a paper dated in 1994, where Michael Mauldin talks about chatterbots, tiny mods, and the Turing test entering the Loebner Prize competition. And that competition is a competition where the contestants, which are programs, enter to compete in an unrestricted Turing test. So that was, the goal was to figure out, is there a program that can rightfully pass the test so that we can say, well, there is intelligence. So here is a snippet of ELIZA. And this is written in a language called MAD, M-A-D, and it stands for MIT Algorithm Decoder. And the language is quite funny, it's very compressed. So, for example, they have, at the very bottom, you'll see there is a command that's T:(H), and that is just an abbreviation so that you could save space. And the part that I highlighted is the entry point to the program, where the operator can select which script they want to run. So let's look at a conversation. And this is a conversation I had with ELIZA just the other day. So I am at Bletchley Park, and I need to give a keynote speech about AI. Can you help me build a narrative and an outline? Is it because you are at Bletchley Park that you came to me? Well, mostly because I need help with my talk. Your talk? Yes, my talk. You seem quite positive. Oh yeah, I am. How long have you been? I think I might have started stout now. You really think so? Yes. You are sure? Now that you ask? No? We're discussing you, not me. Yes, sir. I see. What do you see? Why do you ask? I want to know. What does it mean if you got to know? Nothing. But your talk? Yes, my talk. So, it goes around in circles there, and at the end, you typically get very frustrated. Insert no God, no please meme. So why is it that this is so frustrating? So if we look at the script, this is the doctor script, and you can see at the beginning, how do you do? Please tell me your problem. That's the entry point to the script. And if we scroll down a little bit, you'll see there is lots of stuff going on. And we get to this point here, where you can see that there is this structure which is kind of like a conditional structure. And depending on what you say, it will come up with those answers. And here is one of the answers that it gave when I said, I'm at Bletchley Park. It said, is it because you are at, and for is probably the position of the variable, is it because you are at Bletchley Park that you came to me? And you can see that this is a problem. So everything seems to be so deterministic. So we've had a look at what happened in 1950 and in the 1960s. Let's fast forward to the 2020s, where we have generative AI and large language models, and they help us to build amazing things. And it sure seems like that those machines that we're now talking to, or those models, have some sort of intelligence. And I'm sure you've even heard of people who have AI boyfriends or girlfriends, which is like a really creepy idea to me, but it feels like you're talking to a person sometimes. So I thought, let's try this out. And those of you who know me know that I'm a big fan of The Hitchhiker's Guide to the Galaxy. And the fun fact about me is, before reading the book or watching the video series or the movie series, I played this text adventure. And so I've always wanted to recreate this text adventure. And everything that you see here is something that I recreated using Firebase AI logic. So it's probably pretty hard to read, but I'll tell you quickly what it is about. So we go in, and the game describes the original scene. We are at Arthur Dent's home, who is the main character, and there is a bulldozer that's threatening to pull down his house, and then he has to lie in front of the bulldozer, and then his friend Fort Prefect comes and they leave Earth to go into space. So all I did to implement that was this prompt here, which starts with, I want you to act as a text adventure game engine based on the book The Hitchhiker's Guide to the Galaxy. And everything else in that prompt is just like providing some sort of guidance as to how exactly I want the game mechanics to work. So for example, because of the UI kit that I use here to render the answers, at the very bottom I'll say, return your answers in plain text, no markdown formatting. So I said that I built this using Firebase, and sorry Gus, I used Gemini, not Gemma. And there is a new SDK inside of Firebase, which is called Firebase AI Logic, and I'll show you what you need to do to use it. So here is some Swift code, and this is what you need to do to set up communication with Gemini. So first of all, we need to get a reference to the Firebase AI SDK. Then we need to get a reference to the model. We can pick which model we want to use. Here I use Gemini 2.5 Flash because it's nice and fast. And then we pass in our system prompt, and that is the prompt where I told the model, hey, can you please act as a text adventure engine? And then we can start the chat. Just like that. So just about 10 lines of code to get started. And then this is my send message function, and it looks a little bit complicated, but that's mostly because I need to connect to the UI. And what's really relevant here is the send message function. So that's where I send the user's message to the chat. And you might remember what Gus told you about how models can actually have a conversation with the user. And if you remember, Gus said, models are stateless. They don't know what you said 10 seconds ago or 5 minutes ago. So what we do here, what's happening behind the scenes is that the Firebase AI Logic SDK keeps the chat history for you. So it keeps the user's messages and everything that the user sent with it. So for example, if the user decides to upload an image to discuss something about the image, that image will also be in the history. Also, all the answers that the model sent are in the history as well, so that every new message that you send can refer back to stuff that you mentioned before. So the answer of who is the prime minister would give you an answer, and then if you ask how old is he, you would also get an answer because the model now knows who you're talking about. So let's do this. Let's implement ELIZA. Please tell me your problems. So at the bottom, I'm typing, I am at Bletchley Park. So I didn't speed this up, sorry, it says a little bit slower. And I need to give a keynote presentation. Boom. So here comes the answer. Why do you need to give a keynote presentation? So it's always questioning the reasons. Well, Jason asked me to, is my answer. And then, does it please you that Jason asked you? Oh yeah, I felt flattered. Yeah, let's be honest. What about that made you feel flattered? So, it really drills down into the uncomfortable areas. Well, it's a bit personal. I try to deflect the answer. I've got a room full of people, and I'm embarrassed to talk about this. And then it wants to know more. But the key part here is that really all I did was to provide those 2 lines of system instructions to make that work. So that is everything that it took to create this this implementation of ELIZA. So let's take stock and have a look at the numbers of code, the numbers of lines of code that I needed to write for building an AI-powered app. So there is boilerplate, like the app setup, the chat UI, and so on and so forth. Let's say 100 lines of code, because I'm also using a library that I built. Model setup, 10 lines, that's what I showed you. Calling the model, 1 line. System instructions, 2 lines for ELIZA, 15 lines for the Hitchhiker's Guide to the Galaxy, and you can refine this, of course, right? So my advice for you is, if you want to do that, take your prompt, go into Gemini, or go into AI Studio, and then put your prompt and say, I want to do this, here is what I have, can you improve this for me? And then it'll give you like a massively improved prompt, and that's going to be so much better. So, you know, in the end, you'll end up with maybe 100 lines of system instructions. So all in all, that is 126 lines of code, and that is amazing. That is really impressive. If you compare that with the number of lines of code that Joseph Weizenbaum had to write for his ELIZA implementation, he wrote a lot more, you know. But also it's unfair, right? So he didn't have libraries that he could use. No Gemini. So Andrej Karpathy here recently gave a presentation that was called Software is Changing Again, or the way how we build software is changing again. He gave it at a Y Combinator kickoff meeting. You can find it on YouTube. And he said, LLMs are the new operating systems, and we program them in English. And that is really amazing if you think about it. But well, why is it amazing? Because, you know, it democratizes software development, right? So it means that literally everybody can go and build software now and help them solve their day-to-day challenges. But it also leads us to the question, will we soon stop using high-level programming languages? And will it be, you know, similar to how we think about assembly language, right? So when was the last time you used assembly language? I don't know. Do we have anybody who wrote assembly? Okay, 2 or 3 people. I wrote assembly myself a long time ago, but only because I needed something that was super performant, right? You wouldn't use assembly language to build a mobile app, or you wouldn't use it to build a website, because we have high-level languages. So I think we are at the point where using English as a programming language or as an execution language might still sound a little bit funny, and you might still think, well, you know, it's still too undeterministic, and once I get to a point where I have crafted my prompt so granularly, so detailed that the model actually does what I want, it is very close to a real program, but I think we'll get to a point where this is not unrealistic. So, but who am I to say? And I think Alan Turing should have the last say in this. So what would he say if he somehow had a time travel machine to come to today, look at what we have got, and then write back to a friend in the 1950s about, can machines think? So let's have a listen.
My dearest Christopher, forgive this peculiar letter, but I find myself observing the world of computation from an astonishing vantage point, 70-odd years beyond our last talk. You often pressed me on whether a machine could truly think, and I must tell you, the progress is quite extraordinary. These colossal electronic brains converse with a fluidity that is often indistinguishable from a human. They pass what I called the imitation game with astonishing success, arguing points, writing poetry, explaining complex ideas, all without the interrogator knowing it isn't human. So do they think? My test, you recall, was pragmatic. If the output is indistinguishable, it's intelligent. By that measure, these machines are making a very strong case. Yet the philosophical conundrum persists. Do they feel? Do they understand with an intuitive spark? Or are they simply sophisticated pattern-matching engines? The debate rages on, Christopher, and that in itself is a testament to the profound questions these machines force us to confront. The future, it seems, is even more computable than I had dared to imagine. Warmest regards, Alan.
Thanks. So we are at the end of the keynote. We did promise that there was going to be a demo of Firebase Studio, but because you're running late, we're going to do it in a different way. So I think the next item on the agenda will be our coffee break, and I can read Jason's part here. Wow, how incredible was that? Let's have one more. Huge round of applause for our phenomenal keynote speakers. Absolutely fantastic. A massive thank you to Gus, Rosário, who's still on the train, unfortunately, and Peter for starting our day with so much insight and energy. It really sets the stage for everything to come. It certainly does. All right. This is it.
So we'll take a short coffee break.
We're going to keep to time.
Yep.
11:30, so it is a shorter break than normal, but it means everybody gets their talks, everybody keeps to time, but please make sure at any point you get your refreshments and keep hydrated, but enjoy the break. There's drinks scattered around. Any drinks outside that has not got a cover on, please put a cover on it. We want to protect this, not just for today, but for history as well. So thank you so much.
Thank you.
Enjoy.
Sorry. Jaja, shall I take you to the room you're going to be in?
Oh,
yeah? I think someone's just over there.